Okay. Okay, guys, let's take a look at today's lesson. We're going to be looking at probability today. And for probability, there's lots of different kinds of probability, so let's kind of focus on them one at a time. There's a general, probability in general. We've actually done probability before. I'm sure you did it in Algebra 2, right? And I'm sure you've done it previously as well. So what is probability? Probability is a fraction. It's a ratio of the number of ways, or we can get what we want over the number total ways. It's what we want over total. It's basically what it is. So that's probability. Probability of event is how the number of ways you can get what you want over the total possible things that could happen. Then we have some probabilities that are a bit more complex. It's not just like one thing. So for this probability, we could do like, what's the probability of, rolling a 2 if you roll one dice? Well, there's only 1 2, right? We can only get, there's just one, and there's 6 numbers or 6 sides to the dice, so the probability would be 1/6. That's a real simple probability. Then we have some probabilities that are a bit more complex, like the second one, the probability of the union of 2 events. So if we have, let's say, this is the probability of the union of 2 events. Okay, these formulas would be formulas that you would need to memorize. I'm not going to give you these. The formulas that you wouldn't need to memorize for your quiz would be like the least squares regression, right? You don't need to memorize that. I'm going to give you that formula. But probability is just pretty straightforward. We need to know those formulas. So if I want the probability of 2 events, what I would do is the union of 2 events. What I would do is I would find the probability of the first one, and I would find the probability of the second one, and I would add them together. Now I have to be aware that it's possible that there could be some overlap. If there is overlap, which would be the intersection of those 2 events, then I have to take that overlap out. If there is no overlap, then I would just stop here. I would just add the 2 events together. So let me give you some examples. So let's say we were going to ask you to find the probability of, rolling a 2 and drawing a king. Do they have anything to do with each other? They don't have anything to do with each other, so there wouldn't be anything that I would have to take out, because there's no overlap, there's no doubles. But on the other hand, if I asked you to, what would be the probability of these 2 events? If I asked you to find the probability of drawing a red card, the probability of drawing a king, I would have some overlap, right? Because there are red cards that are kings. So that's what we would have to take out, is the overlap. And I actually have an example on the next slide of that situation where we have an overlap that we have to take out. So we'll look at that specifically. But if there is no overlap, we would just add those together. And so words that you would be looking for in the, the problem is going to be a word problem. The word or, they usually will use the word or. We want to find the probability of this or that. When they use the word or, they're talking about plus. You want to use the probability of this one plus the probability of the other one. Okay? This last, or this one right here, the independent events, they'll use the word and, typically, or they won't use any words at all to tell you. That is where we find the probability of each event and multiply them together. So and is multiplying, and or is adding. Those kind of, we need those stick in our head. Then the very last box over there, we have the probability of a complement. You don't ever have to use this formula. It's just sometimes it is far more convenient to use this formula than to try to do what they're asking. If they're wanting you to find really complex probability, for example, let's say they want you to find the probability of, let's say we have 10 dishwashers, okay? And they want you to find the probability of getting, maybe a good dishwasher or whatever, exactly 1 dishwasher or whatever the criteria is. Exactly 1 is not a problem. It's when they say at least, let's say at least 10. Then we have to find the probability of the first 1, and then the probability of 2, then the probability of 3, and then 4, 5, 6, 7, 8, 9, 10. We have to find all those probabilities when it would be easier to do the not find the probability of the total and then do 1 minus. And I actually have an example for that one on here too. Again, it's nothing that you're ever going to have to do. I'm not going to make you do the complement. It's just sometimes it's more convenient and it's an easier calculation than doing it, straight out what they ask you for. Okay, so we have a problem to go over with that. Questions before we start the problems? Okay, so let's flip to the second slide and let's do some problems. Okay, so on the first one we have you toss 2 6-sided dice. What is the probability that the total of the 2 dice is 7? Okay, so probability is what we want over total. So what we want over total, what we want is the sum of 7, right? That's what we want. But we also need to know what are total possible. What are the total possible rolls that we could do? So that's really the fundamental counting principle, right? We have 2 dice. We have 6 options on 1 dice. We have 6 different numbers, and we have 6 different numbers on the second dice. So we use the fundamental counting principle, multiply those together, and so that total possible is 36. We have 36 different options for this. Okay, so that's pretty straightforward. We have the denominator, but the numerator is a little bit more difficult. We need to know what is the probability that the sum is 7. Well, that's not something that we can just say, oh, well, that's one time. We're going to actually have to calculate it out. We need to figure out what that would be. I typically would do a chart, first dice and second dice, and that's what I normally do. And I think of, okay, so I want to get 7. I could get 7 if my first dice was a 1 and my second dice was a 6, right? I could also get 7 if my first dice was a 6 and my second dice was 1. That's also a possibility because those are different dice. Those are different events. Okay, what else could I do? I could get a 7 if my first dice was 2 and my second one was 5. And the opposite, vice versa, I could get it with 5 and 2. Let's see, what else do we have? What about, we want a 7. What about 3 and 4? If my first dice is 3 and my second one is 4, or my first dice is 4 and my second one is 3, I could get a 7. Are there any other options to get a 7? I don't think there's any other. So there's 6. There's 6 options to get a 7. So my probability of getting a 7, I will just say probability of sum of 7. I like to write that out because it kind of helps me know what in the world's going on. So sometimes you have more than one probability going on at the same time. Sum of 7. The probability of a sum of 7 would be 6 out of 36, which would be 1/6. Now I do want to talk about, there are some on your daily work that have sums that include, like, let's say we wanted to get a 6, or let's just say a 4. Let's say we want to get a sum of 4. Well, we would have a 2 on one dice and a 2 on the other. So the discussion was earlier, is that one event or is that 2 events? And if we use the word events, I think it makes it clearer. So is that one, if one of my choices up here is a double, would I write 2, 2, and 2, 2, or would I just write 2, 2 once, is the question. And we need to know the answer to that. And so if we consider this an event, this is one event. I roll the 2 dice, and the first one is a 1 and the second one is a 6. I roll the 2 dice, and the first one is a 6 and the second one is a 1. What if I roll 2 dice and they are the same? Do I have another event that would replicate this? No, I don't. I don't have another event that will replicate this. I know that it's kind of like, oh my gosh, well, one's a 2 and the other, well, they're both 2s. We can't change that, right, to get the sum. So if there is a double that's involved, it only occurs on this list once. And I really needed to say that because that was very confusing earlier, and it seems logical that you would use it twice. That seems logical, but if you would really think of it as an event, as each one of these throws as one event, it will make sense why this could not be 2 different events. You could not roll, and If you're saying that one dice is 2 and the other dice doesn't exist, then maybe you could do it twice, right? But they're both there. So if you have doubles in the sums, you only count them once. Okay. All right, so the next kind of problem, are we okay with that? Okay, so number 2, the following shows the numbers of colleges and universities in various regions in the United States in 2010. What is the probability that an institution selected at random is one of the 3 southern regions? Now, they perhaps have a different, definition of southern than I do, and that's okay. We're going to go by what they say. Every one of those that has the word south in it, that's the southern region. So if it says south, we're going to include southern, those are the southern regions. That's what that's in their name. So that's what I want, right? The southern region. So I'm going to add those numbers up. So I would do 438 plus 294 plus 797. And I add those regions up and I get 1529. So that's going to be in our numerator. That's what we want to have happen, but we need a total, right? We need to total, and that would be the sum of all of those numbers. So, and I did that. I did my total. I added all those up, and I got 4490. So the probability that we're in the southern region is 1529 over 4490. Now, how we leave our probability is, unless you're told in the directions, it's kind of up to you. Fractions are okay and decimals are okay. I've seen it stated both ways. Sometimes even a percent. They want a percent. So it's totally up to you unless the directions say otherwise. So we can leave it as a fraction and we all would have a calculator. We would reduce it to lowest terms. Or we could turn it into a decimal. This is about 0.3405. If we're going to leave it as a decimal, we need to be at least to the thousandths. I would round to the thousandths. So 0.341 would be my decimal answer. Okay, so if you want it in a decimal, you need at least 3 decimal places. Okay. All right, let's look at number 3. So number 3, we have a lottery, and they're going to choose different numbers from 1 to 44. If these 6 numbers match the 6 numbers drawn in any order, then the player wins or shares the top prize. What's the probability of winning the top prize when 1 ticket is purchased? So the probability of this event, I'm purchasing 1 ticket. There's only one way I can get what I want. The one way would be the winning way, right? We're figuring the probability of 1 winning ticket. Out of, and this one specifically says drawn in any order, so that's good and not confusing like the one on the daily work yesterday. So any order, so that would be a combination. We have 44 numbers to choose from, and we're drawing 6 of them. So we would do the 44 combination 6 in our calculator, and we would get 1 over 7,059,052. Now, some people are obsessed with the lottery. As a math person, this is like, why would you even bother? You only have a 1 out of 7 million chance of getting, 7 million chance of getting the right combination of numbers. Spend your money on something else. So that would be the probability that if you purchase 1 ticket that you would win. Okay. On this one, it probably wouldn't make any sense to put it as a decimal, right? That's going to be like really small. And what does 0.000 mean? That just doesn't give us any information at all. So it really, if it's one like this, you should really just leave it as a fraction. That has more meaning to us than, 0.000. Okay, number 4. You draw 1 card at random from a standard deck of 52 cards. What is the probability that the card is either a face card or a heart or a face card? See this word or? This is telling me that I'm going to find those distinct probabilities and I'm going to add them. Now let's kind of work through it one at a time, and then we'll check and see if there's overlap. So let's just do them one at a time. We want to know, and with they love doing probability with cards, and if you don't know much about cards, then that's probably frustrating. But they like doing it with cards. So there's a standard deck has 52 cards. If there's a heart, we know there's 4 suits, right? Hearts is one of the suits. So the probability of a heart, there are 13 of them out of 52, and you could reduce it to a fourth if you wanted to, just 13 out of 52. That's the probability of getting a heart. So a face card, probability of getting a face card. So how many face cards are in a deck? 12. There are 12 face cards in a deck, so that probability would be 12 out of 52. Now we have to ask ourselves, is there overlap with these categories? Are there hearts that are face cards? Yes, there are. So we're going to have to take those out. So we need to figure the probability of hearts, intersecting with face cards. So how many hearts are face cards? What did we say? 3. There's 3 hearts that are face cards. So my formula, what I'm going to do is I'm going to add these 2 probabilities up, and then I'm going to subtract this out. Basically, I'm taking out the duplicates. Okay? So we'll do 1352 plus 1252 minus 3 over 52. And I left them all in 52, so it would be much easier to calculate with. What does that give us? 22. So that's 22 over 52. If I want to leave it as a fraction, I need to reduce it. So that would be 11/26. That's perfectly fine answer. If you want to put it in a decimal, you certainly can. So a decimal would be 0.423. Either of these answers is perfectly acceptable. Okay? Is that all right? Let's look at number 5. So number 5, we have a random number generator on a computer selects 3 integers from 1 to 20. What is the probability that all 3 numbers are less than or equal to 5? Okay, so let's think about that for a second. So we get to choose any number between 1 and 20, and we want our numbers to be less than or equal to 5. So how many numbers in that interval are less than or equal to 5? Just 5, right? 5 numbers. So the probability of getting a number of 1 through 5 would be 5 out of 20. Right? That's the probability of getting a number 1 through 5 would be 5 out of 20, or 1/4. So we want the probability of, and see there's no and or in here, is there? But it's saying we want 3 numbers. We want the first one, and we want the second one, and we want the third one. I mean, if you kind of think about what word would work best in there, an and or an or, that'll help you determine whether you're supposed to be adding or multiplying. So we want all 3. It's not either or, is it? It's all 3. We want the first one and the second one and the third one. So we're going to multiply those probabilities together. So we're going to do 1/4 times 1/4 times 1/4. That's what we're going to do to get our answer of 1/64. Okay? All right, the last one. So a manufacturer has determined that a machine averages 1 faulty unit for every 1,000 it produces. What is the probability that an order of 200 units will have 1 or more faulty units? Now this one is a bit more difficult because, first of all, it's not saying that it wants 200 units out of that 1,000. It's not saying that at all. It's just giving you a general statistic. Basically, of all the thousands and thousands of machines that this produces, 1 faulty one is out of every 1,000. So this is a bit more complex. And we want to have, what would be the probability that we'll have 1 or more faulty units? Oh my goodness. We would have to find the probability of 1 unit, plus the probability of having 2 faulty ones, plus the probability of having 3 faulty, plus 4, plus 5. Can you see how we'd have to do 200 probabilities? That seems a bit much. Right, so this would be the perfect example of using the complement. Well, if we want at least 1, let's see, we'll have 1 or more faulty units. What would happen if we had no faulty units? None. If we found out the probability of having no faulty units and then we did 1 minus that, wouldn't we get the other probability? I mean, we would. That would give us a probability of any kind of faulty. So let's go through and let's calculate how would we get, what's the probability of getting all of them perfect? Well, the probability of getting a perfect one by the statistics that they've given us is 999 out of 1,000. Right? That's the probability of getting a perfect one. Are you with me? Okay, that's a perfect one. How many of those do I want? 200. I want 200 perfect ones. So I would have to take this times itself 200 times, right? Which is basically this raised to the 200th power. Are you with me? Okay, so I took the probability of one, perfect unit, and I'm doing it 200 times. Why? Because I want 200 units. So this is going to be the probability that all of my 200 units are perfect. So we put that in our calculator, and you're like, does that really work in the calculator? Yes, that will work in the calculator. And we're going to get 0.8186488. We're not going to round until the very end on all these. I think we're about okay with that. Okay, so that's the probability that all of them are perfect. Well, I want the opposite of that. I want one or more to be faulty. So I'm going to do the probability that at least one is faulty is 1 minus 0.818644. 6488. So I subtract those and I get 0.181. That is the probability that one or more would be faulty. Okay? And if you wanted to do an experiment and you wanted to see if the other one turned out the same way, you could. That would be intense and take a really long time. But you could. All right, are we okay with this? All good? All right.